So we're coming together today to talk about beyond the pen test. So how do you go about safeguarding against business logic vulnerabilities? Now, the best reason to run a webinar is people asking you questions. And one of the questions that we tend to get quite a bit is, wait, stop. What do you mean that you guys test for business logic vulnerabilities? You can't test for business logic vulnerabilities. But as Bal will show everyone as we go through the presentation, you can't test for all business logic vulnerabilities, but there's quite a big subset of them that you can. And you can address them within your software development lifecycle. And there are certain patterns that you need to be looking for that we will walk you through. So with that, let's talk about Bal, our amazing speaker for today. So if you haven't checked out on the webinar registration page, Bar is the CTO and co-founder of Right, where we all work. And he has quite a bit of run in the cybersecurity ecosystem. Beyond that, he loves to do a lot of research and he puts out papers, some of them with Bright, some of them more on the academic space. But if there is anyone that you really want to ask, what's new and upcoming in cyber, this is probably the guy that you want to be asking. And he's going to be tackling for us business logic vulnerabilities today. And so let's take a look at what we are going to be talking about. So first of all, what is the makeup of a business logic vulnerability? How is it different from just your plain old run-of-the-mill vulnerability? And what are the telltale signs of that? Obviously, automation. How do you go about testing for it in an automated fashion? And then we're probably going to spend quite a bit of time in our real-world examples section. And then we're going to talk about mitigation best practices. So the Q&A, Bao, please be mindful of your time and leave time for questions for people, even though you want to really go in depth on the examples. And people feel free to push questions throughout the webinar in the chat or in the questions. And if it makes sense, I'll try to, jump in and get Bal to answer it as we go through the topic and we're talking through everything. So with that, I'm going to hand it over to Bob and put myself on mute. So Bob, let's get this show on the road.
All right. So first of all, I'll just grab the control, if you don't mind. I'll just check that it's working. All right. Nice. Okay. So when we are coming to talk about our approaching the concept of business logic vulnerabilities, we first need to define what it is that we see as business logic vulnerabilities. So in short, business logic vulnerabilities are flaws in an application workflow that allows misuse of its intended functionality. A lot of big words to say business logic vulnerabilities are where we use the application's own logic against it. Now, there is a lot of misconception about what specifically is a business logic, isn't a business logic. And this is where we want to do some kind of a, let's call it a differential between those two concepts. So we have business logic vulnerabilities, and then we have something else. We can either call them regular vulnerabilities, or we can call them technical vulnerabilities. Both are fine. Both terms are correct. So let's talk a bit about what's the difference. When we're talking about business logic vulnerability, there isn't a technical flaw. It's a logical flaw, which means that we're not abusing some kind of a technical bug, like let's take SQL injection, for example, right? So it's not that we don't sanitize our input or we have some kind of exception that we didn't handle. Instead, we're using what the developer wanted us to use, but in a way that puts the application at risk. On the other side, a regular vulnerability, okay, or a technical vulnerability is a technical flaw, which means something that the developer did wrong, on a very standard or very bug way of issue. So, for example, input sanitation issue. The developer is pushing data directly into the database instead of using prepared statements or something like that. This is an example. So we have an API call, be it XML or JSON, to reset the user password by sending them an SMS. We have the username field, we have the phone field, and we want to do a technical attack or find a technical vulnerability. One option can be to use the or 1=1 dash dash to try and to create an SQL injection if the phone number is somewhere being used in a query or an operation to the database. Maybe we will find an SQL injection, maybe we won't, but that is the very definition of a technical bug. All right, we're inserting something into where it shouldn't go, and by doing that, we can expose all kinds of vulnerabilities. On the other side, when we have more context and we understand the business flow of the operation that we're executing, in this case, a request to reset a user password, we're passing the user name and we're passing apparently a phone number that the backend expecting us to pass. Instead of passing the phone number that comes from the front-end logic or from the application logic, we can pass our own number, right? A different person's number. And that can allows us to reset other people's password. Now, we didn't inject anything here. The application expected a phone. We gave it a phone, just not the specific phone that it thought it's going to get. And that's the exact definition of a business logic attack instead of a technical or regular attack. So far, so good. We know that we have at least two types of different vulnerabilities, vulnerability families. We identified what is the difference, right? And now we're going to talk a bit about automation. There is a big notion in the industry that business logic vulnerabilities, unlike technical vulnerabilities, cannot be automated. There's a lot of reasons that people say that to be true. For example, those are unique use cases, right? Each application behaves differently, which means that the business logic vulnerabilities will work differently. There is no common pattern between them. Each one is its own different workflow and its own different way of working. It requires human smarts to analyze the context of what we're seeing. A human pen tester is a must as part of the process of exploiting and detecting business logic vulnerabilities, or that it's a complex multi-step kind of logic, and so cannot be automated, but has to be manually found out and exploited. We're here to explain that that's not true. This notion, even though a lot of people are think that this myth is real, it's mainly that it's not that it's not possible. It's that it wasn't done yet. So how do we approach automation? When we look at those vulnerabilities, the first thing that we will want to see is which generic operation or generic behaviors are common between those use cases. And while the business logic vulnerabilities are tied, right, to specific application workflows, banks, marketplaces, shops, tickets for shows, tickets for flights, each one with their own, unique workflow, they often exhibit recurring patterns, such as bypassing validation or manipulating intended processes. So we know that at least the target of what we want to do or what we want to achieve is common across all of those different applications, right? We want to do something specific. There are different workflows, but we want to achieve something. We want to manipulate the data. We want to do something very specific. Now, those shared characteristics allow for the detection of such flows through context-aware analysis. So it's not just going through the different parameters and shove SQL injection payloads or XSS payloads and then try to analyze what's going on. Instead, we need to understand the context of each API call or what we call an entry point so that we can get a better overall understanding on what this operation does, and not just what it does, but what in what kind of category is it? Is this a cart action? Is this a shopping action? Is this a checkout option? Like, what's going on here? And once we have this context-aware analysis of an entry point or an API action, we can start thinking about automation. And by leveraging automation to recognize those patterns, it becomes feasible to identify business logic vulnerabilities across diverse applications. A few examples of things that are such common grounds, right? So broken access control, a common business logic vulnerability that is happening across multiple applications, regardless of what they are. They can be a bank, they can be a project management system, they can be I don't know, flight tickets or your local supermarket where you buy or order food for the weekend. Broken access control can be relevant there. Race conditions, ID enumerations, cart or inventory manipulations, password resets, and discount abuse. All of those are common denominators that we can identify regardless of the application-specific workflow. And through that understanding and that kind of like identification, we can create an automatic process that can find those vulnerabilities. Let's talk about a few examples. But maybe before we go into the examples, just a small reminder: if you have questions, if you want to add anything, if you want to note, the chat is open. We have it monitored. Moran is on it like a hawk. So, let us know. We hear you. Let's take the first example. What do we see here? On the left, you can see two API calls, checkout call. The first one is an API call with a list of items. This is a very standard operation when you go into shopping websites. I don't know, eBay, Tumi, wherever you buy your stuff, Amazon, whenever you want to buy something and it's a shop, right? It has a list of items. Those items behind the scenes correlate into different IDs or UUIDs or some kind of an indicator that the system used to understand it. And so, when you do the checkout, you pass the information of what you want to buy. But in this case, the application also puts the total, right, of all of the items that you want to buy as part of the checkout API call. And we can see that the total is something that the user or the attacker in this case can control. So we go to the API call and we change the total from what it was supposed to be originally, right, into 1. And we can see the response. And the response basically tells us, success, thank you for your purchase. You got your order ID, you got your date, and then the total amount is 1. The currency USD, and you can see it's a bit cut, but you can see below in the items array that the price for the items hasn't been changed. It's it's just that we affected the total amount that we need to pay because the calculation of total sum to be paid has been moved to the front end, and then it can be manipulated. This isn't an SQL injection. This isn't an XSS, right? This isn't an OS command injection. This is just using the system's own logic against itself. And we can see that it's as easy, right? Now, what should a developer do? Or what should someone do in order to take care of that? That is a good question. Moving this logic to the backend, not letting users manipulate or control different aspects of the request in the API call that you don't need them to do, right? Because you have the price. You don't need to let them control the total. Move that away from the user. Or add logic to revalidate, right, the total price per the array of items. That could work. So that's one way to approach mitigation and how to take care of that. Obviously, that will require a QA process to get there. Example number 2. We have a request to a target that handles different projects. It has all kinds of different projects, and the project API allows you to put the project ID as part of the API request. You can see it above in the URL field, right? We have mysite.com, API, v1, projects, and then some kind of ID, and then /view. Now, all we did in this case is we changed to a different user. Basically, we know that this ID is there. We log in with a different user, but we try to access the same object, right? That was originally generated from the server to another user. And the response, as we can see it below, still gives us information based on the request. So we can see that we got the same data that was originally given, but with a different user, which means we have broken access control, or if we want to be a bit more specific here, this is a broken object authorization, so BOLA in this case. Basically, we abused one user's resource and got to it from our own authorization. Again, if there are any questions, feel free to raise them, to ask them. We're listening, we're monitoring. Okay. Next example. In this example, we have a different use case. Basically, we have one API call, right? The post action to API / users / create. And we're creating a new user that's called John Doe, last name Doe. We send this request to the server and we get back status success. message, user created successfully, user ID, and also a role. Now, this is interesting. I don't know how many of you delved into those kind of logic attacks, but this gives us already some interesting information to play around with. I'll give you 1 minute to tell me in the chat what do you think is the attack vector here? Like what can we do here? What's the manipulation? Come on, don't be shy. Throw your ideas at me. While you do that, by the way, just sorry. Moran, can you go back one?
Sorry. To number 2?
Yeah, to this one. Yeah.
Okay.
So while you're giving me your ideas, just about mitigation for this use case, because we didn't discuss that. The best case here for all BOLA kind of tests or broken access control is to ensure that that the user that gets the information is also the user that is the owner of the object. So in this case, if this is my project, only Bar should have access to this project. All right, so the object is not available to everyone who has access to the application, but the object is bound or tied to a specific user entity. In this case, this should have been only accessible to user A, but when user B would like to try and get to it, they should get some kind of like 403, 401, some kind of like an authorization error that's saying, hey, you're not supposed to watch that, right? You're not supposed to get access to this resource. Okay, we can go back to the example number 3. So let's see
Going
what you
back to
said.
example number 3, we only have 2 brave people in the audience who are willing to put themselves for 3. I'm sorry.
Okay. So let's see. First, we have the user can do anything because the user is an admin. In this case, by the way, the user is still a user, right? But once the user is admin, then yeah, of course, they can do almost anything. Alex says injection fields that exist in data scheme but not supposed to be posted. You're getting there, very hot. No sanitation for the payload received by the server, allowing malicious user to pass new parameters that affect RBAC. For the win, yeah, no. I got where you were going with it, but for the win is Alex's response, number 2. This is what we call in the industry a BOPLA. It has silly names, right? It's broken object property level authorization, if you want to break it down. Basically, when we do in the server side, we have everything as different objects, right? We have users. The users are a class or a struct or some kind of a data object that usually we will initialize, especially if we take this data from the client side. We will initialize it from some JSON or XML or some kind of input from the user. Now, most developers will just use the mass assignment way of doing things, basically saying, listen, whatever coming in through the JSON, just parse it. We're not going to go field by field, just parse the whole thing and initialize the object through it. When the object was misconfigured, or you allowed the user to have one of the properties dynamic or able to be manipulated, what we basically caused here is that the user, once seeing the response that showed role user, now the attacker knows that that this role property exists, and now it's just a matter of figuring out which roles are available in the server and try to affect them, manipulate them, add all kind of data to it, try and see if we can change the value. And indeed, by adding the role property to the post request to create a new user, we affect the server-side logic and add our user as an admin. This is a very, very, very risky situation because this is both, this can be used for a lot of things. The classic example, of course, is like privilege elevation, but this can have so many other different risk options, especially when you go through the list of properties that you get back in the get and try to see things that you should not have access to, like accessible, let's say it's a project management system, so accessible projects, and you have like IDs of different projects that you can have access to. What if I just add more projects there? Do I now have access to more and different projects? Or if I have, I don't know, something, let's say, I'm sure at least some of you are playing, computer games. Think about achievements, right? Which achievements do you already have? If you get it in the get, can I change it in the post? If I have discounts, right, attached to my user, can I add more discount? Can I change the discount? Can I add credits? Let's say, right, AWS, etc., services that give you credits. The credits are part of your user profile. Can I, by creating a call to change my username, can I affect other things that are saved in my user profile? Right, so there can be a lot of very different and let's call it risky consequences. All right, so that's our last example. And can we go to the next slide? Now let's talk mitigation. And this isn't specific mitigation for each use case because we already discussed that. This is the general mitigation. So first, I asked ChatGPT because, all developers out there, that's basically our new thing or everyone's new thing. We asked ChatGPT for answers. And as a developer, I went to ChatGPT and I'm like, okay, how do I mitigate business logic vulnerabilities? And the answer is, a very laconic one. Mitigating business logic vulnerabilities require comprehensive input validation and strict enforcement of application workflows to ensure all actions follow intended business rules. Good. If that was the case, we wouldn't have them to begin with, right? Basically, what ChatGPT suggests is develop properly and do QA. Thank you very much. We needed AI to get to this conclusion. Thanks God for the AI revolution, right? So basically the suggestion is more QA, all right? More tests. But And here we come to the root of the issue. Right now, if we fall for the common myth or common thought pattern that business logic vulnerabilities can only be found by manual work, either of a pen tester or a QA engineer, that means we're leaving our application open. Because like any other kind of testing, especially on large scale situations, no human is able to go through each and every entry point, each and every API call, and validate it for all use cases. It's not humanly possible. And also, when you want to do any kind of development at scale and at speed, that's not something that you can live with, right? You want to release, even if you want to release every 2 weeks, every 1 month, you don't have the time, all right, at the end of your release cycle to start a 2 weeks worth of QA and like manual QA and pen testing. That's not going to fly. And this is why we need to look at other avenues and how do we attack this problem. Now, other options or other answers that people have is, we have WAF. We have some kind of runtime protection. Runtime protection protects you from, if it even protects you from technical vulnerabilities. It knows to detect patterns of, SQL injections, of XSS. It can find, specific tokens, specific payloads, and alert, and cancel those kind of requests. But when we're talking business logic vulnerabilities, this endpoint should accept phone numbers. I'm just putting a different phone number. The WAF doesn't even understand that I'm doing anything wrong, right? I'm changing the integer for the total price of something. That's not, I'm not doing anything malicious in that concept. And this is why those kind of vulnerabilities are so much more problematic than your standard technical ones. Even in the logs, when you want to monitor, when you want to go back and see what happened, right? Suddenly, you just shipped 2 tons of product for $2. How did that happen, right? So you go into the system and you go through the logs. There isn't a hack. There isn't a breach. No one is inside of your network stealing stuff. People just abused the way that you thought your system is going to behave in a different way. So WAF isn't going to help us. Firewall isn't going to help us. Runtime security is not going to help us because nothing malicious happened. We just abused and manipulated the application. So what can we do? And I think this is where we can have a bit more of a open discussion here. And I'm still looking at the chat.
We do have two anonymous questions, which honestly, my feelings
Ooh.
are hurt. But we have two anonymous questions, but I think they're just fitting into what you're talking about now. So I was waiting patiently.
Okay. So you want to raise them or you want
Yeah.
to?
So
No.
I think before you start talking about what we can do, there was an earlier question here asking for examples to distinguish between, the cases that we discussed, which are BLVs that can be tested automatically, versus something that wouldn't be a BLV and would be a custom test, or something that would be a BLV that you could not run an automation for. So trying to figure out, what the difference would be between something that is really custom to your logic versus something that is called a BLV, but actually does have a pattern that can be tested for automatically.
Got you. Okay. Interesting question. So I would say that a business logic vulnerability, which can be automated, falls into, and I think, can you go to slide 9 for a second?
I can try. Tell me when I'm at 9.
This one.
Okay.
Okay. So whenever we talk about what we can automate is something that falls into those recurring patterns, right? Those kind of categories and scenarios that are, even if it's called a bit differently, or the UI looks different, or one is a shop and one is one, I don't know, in one place you're buying food, in the other shop you're buying I don't know, flight tickets, in another one you're buying clothes. Even though it's different applications, there are same actions that are happening. We buy stuff, right? We pay, we create users. Those users have different permissions. So whenever we have those common grounds, we can create automation. Now, what are things that are outside of this kind of logic? Are things that are very, very, very specific to an application um, that has no generic use case. So, for example, let me think. We have we have an online game. The online game communicates with the server behind the scenes to let the server know whenever you, I don't know, you do something, right? Whenever you open another section of the map, whenever you encounter another user. Um, uh, we can manipulate that to, I don't know, move quicker through the map, explore places without actually going there. But this is a very specific behavior for a very specific application, or a very specific situation. Um, so any kind of similar cases where we have a logic or behavior or a workflow that is application specific in logic. I don't know. I can. I don't know. I don't have another good example now. But basically, in large. And by the way, give me your examples. If anyone has an example of something that is very specific and they think that doesn't have any kind of a generic use case, tell us in the chat, and I can tell you if that's something that can be automated or not. But basically, anything that falls into a generic workflow, we can automate, and that is like the 90% cases. The other 10% are things that are either very application specific or are just not risky enough to to go through the trouble of doing the testing for.
Okay. So bringing us to our next question, then going through the trouble. So someone here is asking, how far is too far in implementing strong protections from business logic vulnerabilities? Are we at risk of placing ourselves in a position where in the position where security is stifling our normal, regular operations? I think the emphasis here is testing versus runtime, but take it away, Bob.
Okay. Um, this is a very I can say that this is a a generic or general security question. Um, when when is what we're doing counter effective? In the end, security in large needs to enable operations and growth, because when it goes against operation and growth, it won't be um, um, uh, uh, it won't be embraced by the organization, and it won't be effective. and it's just not going to work. And this is like talking from my CISO hat. So when you're talking about when it's too much security, or when are we actually doing too much that it's becoming counter intuitive, I would say anything that isn't automated, anything that require us to stop processes like development processes, like testing processes, while we wait for things to happen, is counter effective and won't work in the real world. Um, so when we're talking about what to do, I would say automate as hands off as humanly possibly. So autonomous automation, trying to create processes that inform but do not block, and if they block, make sure, and this is a very big, question mark. Make sure that when you block operations, you have a very good reason to do so. I think that's my answer to that. I hope that was good enough. If not, then you can ask follow-ups, either anonymously to Moran or
Yeah, I'm
in the
going to
chat.
disable the anonymous ones for the next time around, I think. But last anonymous one here, and it's a bit more specific. Um, is LLM security testing considered a category in itself, or is it a business logic vulnerability? And how are the two different?
Nice question. I would say that it is both. And that's maybe a bit annoying, but when we think about it, right? When we can you go back to the first slide? This one. So we're saying, right, that business logic vulnerabilities are flaws in an application workflow that also misuse its intended functionality. When our application is an LLM application, like a chatbot, or has some kind of an LLM integrated into it, the intended functionality is to have an LLM in it, which means that this chat or chatbot integration is part of the intended functionality of the system. And when we misuse the LLM in order to do all kind of things, I would say that falls into the broader definition of a business logic vulnerability, especially because there is also a level of context that needs to be understood. Having said that, it is not a par excellence, or it's not the exact definition of business logic vulnerability, and as such, it usually will fall into its own category, because you can do things with the LLM that go beyond the concept of a business logic vulnerability. It's not just attacking the application's intended flow. You can also create, and that's something that I'm talking about in my uh, LLM security webinar. But you can use the chatbot to execute technical vulnerabilities as well. So you can make the chatbot do an OS command injection, or at least path traversal in some cases. You can use the LLM to do OS command injection or XSS, right? That's the whole concept of the insecure output handling. And because you can do all of those things, then it is a bit of its own category. It can go either here or there, in that case. So it's both and neither.
Open to your interpretation, basically. Okay.
Exactly.
Um, any more questions, feel free to put them in the chat, but all the anonymous ones have been answered. And the next person that asks something, please use your actual name. But now we will let Bao talk
Yeah.
about what you can actually do.
Yeah. So Carlos just said that it seems to be something complex to control with some automatic solution. Um, I guess what you mean here is that the LLMs are something that it is complex to control, or you mean testing for LLM security is something that is complex to do in an automatic use case? Um, I'll keep an eye if you want to add to that. So our last so testing. Testing for both business logic vulnerabilities and LLM vulnerabilities in an automated fashion is indeed complex. But the good thing is that it's complex to the vendor. It shouldn't be complex for you. So if you go for an automated solution that does those kind of tests, then hopefully the vendor of that specific solution has made it hard on themselves to make it easy for you. But in the end, it's automation. It should be automatic. You should not be part of the process either than a first configuration and then letting it run. But yeah, automatically testing for those kind of things is technologically complex, which is also why we're very proud to have that in our solution as well. So let's talk about, we went over what we should do in specific use cases. And then we talked about what we should not do or what's meaningless to do. Let's talk about mitigation. I have something to say that a lot of DevSecOps and AppSec engineers would really dislike hearing. And that is the notion of developers becoming security aware or learning to code securely is a dream that will not come into fruition. And as such, expecting salvation for those kind of issues to come from the developers by them creating more secure systems is something that is doomed to fail from the beginning. So what we should instead do is ensure continuous testing and continuous validation throughout the software development lifecycle. And this is where comes the mitigation. We want to figure out, to test as soon as possible and as shift left as possible, right? That those kind of vulnerabilities do not exist in the code base before it goes out into production, before it goes out into actual use. And we should do that by running as many continuous tests as possible without harming our first order of business, which was never be counter effective to the development processes. So this should be a hands-on workflow where, for example, let's say I have a CI/CD pipeline. Let's say GitHub, just because it's the easiest to think about, at least for me. We have our CI. The developer writes some code. They push this code into their branch, some kind of either a development environment, pre-staging. If you have GitOps and you're more mature, then there's a whole instance building through for that specific PR that has been opened. Test there if you can. If not, then on your CD, where you have artifacts being created and generated just 1 second before you push them into the QA cycle, run the tests there and run them continuously with automated tools, because that's the only way where we can both validate that those issues do not exist and not involve human interaction. And I think that's it in a high level. We have 5 more minutes, so I think we can go to our Q&A. If anyone want to ask anything, and I love to expand on that. Just we don't have a lot of time left, and I promised Moran at least 5 minutes for questions.
Okay, Carlos, thank you for using your real name.
Yeah, so
Go ahead and read Bar.
oh, no. I'm, right here
I'm
stealing.
capable. Okay, so I will read what Carlos asked. Use using ethical hackers a good idea.
So using penetration testing services, be it in this case, I guess when you're saying ethical hackers, you mean like bug bounty platforms. It's always a good idea. Security is layered, right? But when they find it, it means it's already in production. And it's not consistent. Sometimes you will have a bug bounty hunter that is very, very good at what they're doing. Sometimes not so much. Sometimes someone will remember to check this one specific API endpoint that you can only get to if you dive 6 layers deep into the application, but most likely it will not be tested. And this is the fault of humans, right? We're not built for automation. We're not built for consistency. We're here to do the human part, right? We're here to do creativity, to do problem solving, to do logical operations. We're not good at doing continuous menial work. And if you want to do to get to actual good coverage of security on your platform, it can never just be a human person doing it, because that will fail. So is it a good idea? Yes, it's a good idea to have that. Is that the answer to business logic vulnerabilities? Certainly not.
So I think just to wrap up everything that Bala said, and if anyone has other questions, feel free to send them directly to Val, to put them in the chat, or to email me, and we'll already get to them in the follow-up. But to wrap everything up, like, take everything in perspective. When you guys were getting started, you didn't have a lot of the tools that we had today. And we had this, need and preconception that we need to write tests for everything. No one tries to write their own set of tests now for the technical tax or for the API tax. And if you want to take a leaf from another book, no one would probably try and write their own authentication flow. We have off-the-shelf tools now if we want to do single sign-on and if we want to do authentication and so forth. Just in that is the way we should be looking at BLVs. There is a way to automate them, and just because we don't always know how to look at them and clear out that special flavoring that is our application doesn't mean that there's a pattern here that at some point just should become a test in our library that all of us will think is absolutely normal that we should be running. So take that in consideration. And if you want to talk more about the specific BLVs, or if you want to go into a use case that you guys have and have us discuss it with them, with you all to figure out if it is just you or this is actually a BLV that you could automate for, feel free to come back to us with examples from your applications or the use cases that you're working on. And we're happy to talk to you about them and figure out, is this a custom test or is this a BLV that you should be automating for? And with that, snap a screenshot, get Val's contact details, and I will also send it up in the follow-up. So thank you very much, Val, and thank you very much, everyone who actually joined on time and stayed to the end, which is flabbergasting. Okay. See you all next time. Thanks.